This is ACT Math Manual Section 12. This begins on page 87. Section 12 deals with basic equations and expressions, so just a lot of algebra in this section. Now, as the name implies, yes, most of this stuff is fairly basic, and for a lot of students, it's not going to pose much difficulty, so hopefully this video will be quick and painless. For those of you that do tend to struggle with solving and manipulating basic equations and expressions, you are going to most likely need to do a little bit of extra work on your own or to talk to your tutor about some of the areas that you need further clarification in. This video will be more of a review. It will not be so much delving into the depths of basic equations and expressions, considering the fact that by the time you take the ACT, you should have been doing this stuff for about 5 or 6 years, maybe more. So again, a lot of this stuff I'm just going to be touching on some things, and if anything is unclear to you, you're going to have to go ahead and make sure that you shore up any weak spots. Now, first things first. As I have said, the basic equation questions on the test, yes, they are generally very simple, very basic. However, they do provide many, many opportunities for careless mistakes. And if you are not being extremely meticulous, meaning working one step at a time, meaning writing out all of your work, you're going to make a careless mistake and you're going to end up missing a question that you shouldn't miss. So you can see on number 1, which is already done for you, solving a basic algebraic equation such as 3x over 2 plus 16 equals 10. I should have circled that because that's what they're asking us for. But solving this equation would require writing out all of this work to make sure that you are doing everything exactly as you need to. Now, on number 47, this one is definitely a little bit tougher. I'm going to have you go ahead and try it. You might want to press pause on the video. I'm going to work through it right now. So if x over 6 plus x over 4 equals 1/2, then x equals. There are several ways to do this question. And by the way, if you are really struggling, you could use one of our tin techniques on this question. You could use nidus, which would entail taking these answer choices, for instance, taking 1/5, plugging it in for this x and this x, adding the two fractions together and seeing if you get 1/2. So you could use a tin technique to save you here if by some chance you could not figure out the algebra. I'm going to go ahead and do this I'm going to actually do it in 2 ways. One is I'm going to find a common denominator over there on the left, and that common denominator would be 12. So I get 2x over 12 plus 3x over 12 equals 1/2. This is 5x over 12. Remember, I just add the numerators. I do not add the denominators. 5x over 12 equals 1 over 2. I then cross multiply and I get 10x equals 12. Notice I am writing out all of my steps. I get x equals 12 over 10, which I could reduce in the calculator, but I'm going to go ahead and do it in my head. It equals 6/5. Let's make sure they were asking me what x is. Yes, they were, and my answer is D. Now, there is one other way to do this that I'm going to point out. It is similar to finding a common denominator. I mean, it does virtually the same thing. But one of the things that you can do if you have a variable in the numerator of a fraction and you want to sort of get the variable alone, you want to make bare the variable, what you can do is you can go ahead and multiply through by the thing that would clear these denominators, and that thing indeed would be this common denominator. In other words, if I multiply this entire equation through by 12, this 12 and this 6 will cancel, leaving me with a 2 up in the numerator. The 12 and the 4, remember, I'm distributing this 12 to all 3 of these terms. 1, 2, 3. The 12 and the 4 would cancel, leaving us with a 3 up in the numerator, and then the 12 times 1/2 is 6, and I end up with 5x equals 6. Divide by 5, and here I don't have to reduce at all. I just have the answer. So again, if you do have a variable and you want to clear away the denominator under that variable, just multiply by a factor that will clear that denominator. And if you have multiple denominators, you might want to multiply by the thing that would be your common denominator, because that will likely clear all of your denominators at once. Now, like terms, spotting and combining like terms. First things first, you have to know what the heck a like term is, and a like term is this right here. A like term is, or like terms, I should say, you have to have multiple terms in order to have like terms. Things with the same base, and remember that base does not have to be a variable, it could be a number, but things with the same base and the same exponent. So x squared and 3x squared. These are like terms because we have same base, same exponent. N cubed and negative n cubed. These are like terms because I have same base, same exponent. N cubed and negative n squared. Well, yes, I have the same base, but I do not have the same exponent. These are not like terms. I cannot combine these terms. So you might want to run through examples 1 through 7. Some of these are going to be difficult for certain students. Others should be pretty straightforward. Go ahead and run through them right now. Pause the video and then come back and join us. Example 1, let's first determine if these are like terms. Do we have the same base? Yes, we do. A p and a p. Do we have the same exponent? Yes, we do. A 3 and a 3. What do we do when we have same base, same exponent? In other words, when we have like terms, well, what we do is we just add or subtract. We just add or subtract the coefficients. So what's the coefficient in front of this p cubed? It is a 1. Very good. I heard it from the back of the class. Somebody said it. 1p cubed minus 3p cubed would be negative 2p cubed. Example 2, so do I have same base, same exponent? The answer is no, I do not have the same base and same exponent. The exponent on this x over here is a 1, and on this x over here is a 2. On this y over here is a 2. On this y is a 1. So I cannot add these two terms. If you put, can't do or no or nothing or whatever you want over here, that's fine. You can clean this up a little bit, or you can simplify a little bit by factoring. You can pull out an xy. There is an xy that is common to these two terms. And what you would need in parentheses in order that when you distribute the xy, you get back the original expression over here, you would need a y here and an x here. And then when I distribute this xy back through, I get xy squared plus x squared y, which is what I had over here. So you can factor, but because these are not like terms, you either just need to keep this expression the same or, as I said, factor. Now, example 3 is just to show that, remember, multiplication has what is known as the commutative property, which means that BA and AB are exactly the same thing. In other words, when you're multiplying two things, the order of the things you're multiplying does not matter. So this term over here, BA, could actually be written as AB. So we would have 4 ABs, take away 1 AB, which would leave us with 3 ABs. In example 4, these are not like terms. I do have the same base, but I do not have the same exponent. This exponent over here is a 1. This exponent over here is a 2. So there's nothing I could do there. Again, I could factor on that question, but I'm not going to do that right now. Example 5, this one sometimes stumps students, mostly because of these fractional exponents. These fractional coefficients. They just throw students for a loop, but there's nothing different here from what we did in example 1 or example 3. We have like terms, the q, and the q is the base, the exponent is a 1. So we just have to add these coefficients, and in order to add these coefficients, what do? We find a common denominator. No, we don't. We do not do that because we have a calculator. So we do 1 divided by 3, we hit enter, we add that to 1 divided by 4, we hit enter, and then we math enter that bad boy, and we get 7/12. So yes, you could have found a common denominator, but there's really no need to do that when you have a beautiful whoa, that's an M, $120 calculator or whatever these things cost nowadays. So this would be 7/12 Q. Now, example 6, a lot of students immediately look at this as a distribution question where they start distributing this 3. I'm going to zoom in on this a little bit. They start distributing this outside 3 to the inside terms. And if you did that, that's fine. It's not like you're going to get the wrong answer, but you should keep in mind that this also deals with order of operations, and we have parentheses here. And when we're doing order of operations, we always do what is in parentheses first. So this would equal 3 times, this is negative 1t plus 3 t's, which would give us 2 t's. So this answer here would just be 6t. That's probably the easiest way to attack that question. Now in example 7, again, this is yet another one that tends to throw students for a loop, mostly because students are just not used to seeing these weird decimal coefficients, but we are not doing anything different than what we did in example 5 or example 3 or example 1. We have like terms. The w's are our bases. The 1's are our exponents. So we do have like terms, same base, same exponent. So all we do is add, or in this case subtract, the coefficients. So we have 0.01 minus 1, 0.01 minus 1. And we get negative 0.99w. So 0.01 w's, take away 1 w will give us negative 0.99 w. So again, I know for some students that was probably very simple. For others, you might have had a little bit of hesitance, a little bit of difficulty, and if you did, that's fine. Just make sure you do whatever it takes to get those skills solid, because you will need them very frequently on this test. Now, distribution is yet another fairly basic concept that is complicated by careless mistakes. Distribution questions on the ACT almost always involve distributing negatives. And if you are not being extremely careful with the distribution of your negatives, you're most likely going to make a careless mistake. Before we do number 6, I am going to make a note that you do have variables in the answer choices here. So if you absolutely needed to, you could do Vita. For those of you that have done that section of the manual, you know you could list your variables, throw in a number, plug that number in for the x's here, solve this completely arithmetically, get a boxed result, and then find the answer that equals the boxed number. But we're going to go ahead and do this algebraically. So the distribution, here's what I'm going to do so that I don't make any careless mistakes. I'm going to actually write down the entire expression again. I'm going to draw my distribution arrows so that I keep in mind what is being multiplied by what. So this is a 2 times a 4x, which is an 8x, a 2 times a positive 7, which is a positive 14. Now this is a negative 3 times a 2x, which is a negative 6x, and then a negative 3 times a negative 4, which is a positive 12. And now I can start combining like terms. The 8x and the 6x are like terms. I just subtract the coefficients, I get 2x. The constants, the 14 and the 12 are like terms. I add those together and I get 26. So my final answer should be 2x plus 26. They were asking me for an equivalence, and that is what I found. So my answer is H. Not really solving. Section 12.3, not really solving. So there are some questions where you are not looking for a numeric solution of a variable. You are simply trying to figure out what one variable is in terms of another. So I'll just do like something really silly and simple here. If I had 3x equals 2y and somebody said solve for x, well, what would I do? I'd divide both sides by 3 and I would get x equals 2/3 y. And now I have solved for x in terms of y. I have expressed x in y terms. I have expressed x in y terms. So there are going to be some questions where you have to simply manipulate, where you don't necessarily have to solve for a variable's numeric value. 32 is a good example. I'm going to say one more time, if you do have trouble on a question like this, you can use Vita. There are variables in the answers, so you could throw in numbers here as long as you're careful about the fact that m and v are dependent variables. You can't throw in whatever you want. You have to make the equation work with your numbers, but this question is fairly simple with Vita. It is also fairly simple with algebra, so I'm going to go ahead and do it that way. So they're looking for v, which means I have to solve this equation for v, or I should say, again, I have to manipulate this equation to get v in terms of m. So I have m equals 3v plus 6. I subtract the 6, that's my first step in isolating the v. I get equals 3v. I divide both sides by 3, divide both sides by 3. I get v equals m minus 6 over 3. Now I am not going to separate these into two different fractions, such as m over 3 minus 2, because ACT has already given me this expression in the answer choices. So this is m minus 6 over 3. Again, just had to manipulate. Here's the note on VITA. I did say you can use VITA on questions like this, but the algebraic solution does, for, I would say, most students, tend to be fairly simple. Now, in terms of plugging in, so we have talked by this point in the manual, we have done VITA, we have done NITIS. I've made many comments about throwing in numbers and how effective a technique it is. Well, there's going to be some questions where ACT has already set up the throwing in numbers for you, because they will just give you some values of variables like they do in number 13. They give us a equals 4 and b equals -2, and then they give us an expression that needs to be evaluated when the variables have these values. So on a question like number 13, which you might want to try on your own, the only thing you need to, once again, be very careful of is that you are dealing with negatives, and you are dealing with subtraction, and you are dealing with exponents. And when negatives combine with subtraction and exponents, again, careless mistakes do become a risk. So I would suggest taking these a little bit more slowly than you normally would, at least at first, and make sure that you're being meticulous and you're not making careless mistakes. So I'm going to go ahead and do this one right now. So this is 2a minus b, which is, I'm going to actually do this. That's my b. So 2a minus b, and that was all in parentheses, plus b, and I'm going to put that in parentheses, to the a. So that is -2 to the 4th. Now, some students do make the careless mistake of thinking that b to the a, when b equals -2 and a equals 4, that this is just -2 to the 4th. But that is not correct. This situation right here is not the same as this situation right here, and it is this situation right here that we're dealing with. This is b, the entire value of b, to the a power, and the entire value of b is -2. So this would be, again, b, which is -2, to the 4th power, which is why I have written what I wrote. So 2a, oh, wow, okay. You might have wondered why I was doing that, and now I'm wondering too. It was because I was being careless. This shouldn't be an a, this should be a 4, so I apologize for that. So 2 times 4. So this is 8 minus -2. 8 minus -2, which is 8 plus 2, and then plus -2 to the 4th. Normally a good idea to do that in the calculator, but that is 16. So this is going to be 10 plus 16, which equals 26. That is what they were asking me, and I am done. Next, I have what polynomial must be added. Going to make the note one more time. Notice we have variables in the answers, so there is, if you are having trouble with a question like this, the opportunity to use VITA. And actually on this one, I am going to show you what it looks like here, just for the heck of it. So the question is saying the sum of -2x squared plus 2x plus 8, and which of the following polynomials is 5x? So 5x squared plus 3. So if I use 2 here, and some of you may have heard me make the notes. I'm not sure if I made it in VITA, but there is a possibility that using 2 on a question that has a bunch of squareds in the answer choices, using 2 might cause doubles, but I'm going to go ahead and use it anyway. So this is the sum of -2x squared is going to be -2 times, when x is 2, that's going to be 4. So that's -8, and then plus 4, 2 times 2, plus another 8. So that's just 4. So the sum of 4, and which of these is going to be, this is 5 times 2 squared, so that's 20, plus 3, this would be 23. So the sum of what and I'm sorry, the sum of 4 and what would be 23? Well, I'll just do 23 minus 4. So I am looking for an answer choice that equals 19. That's what I am looking for, an answer that equals 19. When I go to my answers and start throwing in the 2's, so this would be 3 times 9 plus 3 times 9, so that would be 27 plus 2 times 2, so that's 4 plus 11. Well, that's obviously not going to be 19. That's going to be much bigger than 19. This is going to be negative 7 times 4, which is negative 28. And then I am adding to that 4, and then I'm adding to that 5. So that obviously doesn't work. That's going to be some negative number. It is not going to be 19. This one is going to be positive 28 minus 4 minus 5. That's 28 minus 9, which indeed is 19. So that one does work. This is, again, going to be negative 28 plus 5. That's going to be a negative number. This is going to be 28 minus 5, which is 23. So it looks like answer choice H is the only answer that works, and I'm done. So that's how you would apply VITA on a question like this. Now, in terms of the algebraic solution, the way that you would want to do a question like this is sort of one column at a time, or one pair of like terms at a time. Now, what do I mean by that? Here's what I mean. I'm going to actually clean this up so that we can all see what the hell is going on here. Get rid of all of this. So we are going to do this. We're going to say, well, we have to get negative 2x squared plus 2x plus 8, and we have to add something to that. We have to add something to that because we're dealing with a sum to get 5x squared plus 3. So what do I have to, so what I mean by doing one pair of like terms at a time, or one column at a time, is this. I'm just going to focus on getting from negative 2x squared up to the 5x squared, and what do I need to do? I would need to add a 7x squared. So I know right away this answer, which has a negative 7x squared, this answer, negative 7x squared, this answer, which has 3x squared, those are all gone. And now I'm down to 50-50. In order to get from 2x to, well, remember, there is a 0x here. You might remember from quadratics, you know, when you have a quadratic, you have ax squared plus bx plus c. So the 3 is our constant. The 5x squared is our ax squared term. Because there is no term in the middle, that's a 0. That basically means this b coefficient is 0. There is 0 x's here. So to get from 2x to 0x, what do I have to do? I have to subtract a 2x, and that seals the deal. We know the answer is h, because h has the negative 2x and k does not. So that's how you do a question like that. Again, you could use VITA on a question like this as well. So that is actually it for basic equations and expressions. Again, probably the most important thing here is to make sure you are writing work and being meticulous so that you are not making careless mistakes. These questions are generally fairly simple when you see them, but if you are not being careful, you may not get the points that you should be getting. That is it.